Okay, so what they're asking us for on this question is to do some long division. And specifically, they say what they want to do is find the greatest common divisor of 374 and 98. What do you think? What is the greatest number that divides evenly into 374 and 98? What's the biggest number that goes into 374 and 98? Honestly, personally, I have no idea. You know, I know 2 goes into both those numbers, but maybe there's something else. Maybe there's something bigger that goes into both those numbers. I don't know. That's what we're trying to find out. That's what the GCF or GCD, those are the same. GCF and GCD are 2 ways of saying the same thing. They are the same. They're asking us to find the greatest common divisor, greatest common factor for 374 and 98. What's the biggest number that goes into 374 and 98? What's the greatest number that we can divide into both of those numbers? So how do we find it? Well, we've got it. This is a new way called the Euclidean algorithm from Euclid. He's a math science guy, long time ago, came up with this method. So what we're going to do is we're going to basically do long division. So I'm going to go over here on the side, and I'm going to go, in fact, actually, you know, probably best, let me move this where we've got just a little bit more room so we can write out the whole thing and not have to squish everything in too badly. Okay, so I'll move it down here for us. There we go. All right, so let's do it. So I'm going to start with the 374. So I'm going to go 98 into 374. So you just do long division, and then over on the side, I'm just going to write what I'm dividing, and I'm going to do it on my calculator. I'm going to take 374. I'm just going to use my calculator for all this stuff. 3.8, blah, 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 blah. So that means you just grab the whole number. It goes in a whole number of 3 times 98. And that's 294. Subtract. And I'm getting 80. So that's the remainder, isn't it? So when I divided 98 into 374, it went in 3 times remainder 80. So the quotient is 3, the remainder was 80. 374 divided by 98 equals 3, remainder 80. That's the answer. Good for the first line? Is that making sense on the first line? And now we rotate, meaning the 80 comes up here and the 98 goes in there. That's the weird part. So here's the strange thing you do in the Euclidean algorithm. An algorithm just means like a recipe, steps. It's the Euclidean steps or the Euclidean method. That's what it's basically saying. It's the method that Euclid came up with for finding the greatest common divisor or factor. You do long division, and then you do this weird rotation thing, almost like a clock, right? It's rotating clockwise. The 80 goes out here, and the 98 went in there. See how everything rotated? And then you do the long division again. We're just going to keep doing this. So over on the side, use my calculator, 98 divided by 80. And it's coming out 1.225. So that's 1. Just grab the whole number, right? We just grab the whole number every time. 1 times 80 is 80. Subtract 18, remainder 18. So what did we just do? Now they want you to write on the line what you did. What did I just do? I did 98 divided by 80. And the answer was 1, remainder 18. Is that good? Now, let's do it again. This rotates this way. The 80 rotates in there. You just do the clockwise rotation again. So it becomes 18 out here, 80 in there. See how we just keep rotating? And over on the side, I'll use my calculator. 80 divided by 18. I'm getting 4.444, blah, blah. Grab the whole number. 4 times 18, 72, subtract 8. That's the remainder. So I did 80 divided by 18, 80 divided by 18, and it was 4, remainder 8. Do it again. We got 2 more steps. So the 8 goes up there, the 18 goes in there. You just keep rotating, right? So it's going to become 8 into 18. And do that over on the side. 18 divided by 8 on your calculator. It's 2 times 2.28. This was probably easy enough. You probably know. 2 times 8, 16, remainder 2. So what did I just do? 18 divided by 8. 18 divided by 8 is 2, remainder 2. All right, one more step. We have to keep going until we get a remainder of 0. So last step, this 2 will go here, the 8 will go there, right? We just keep doing the same rotation. I'll bring it over here. 2 goes into 8 now. See how we rotated it one more time and bring it over here? That one's easy. 2 times 4 is 8, remainder 0. There it is. There's your, we're done. When you get a remainder of 0, that's the signal that you're done. What did I just do? I just did 8 divided by 2, didn't I? 8 divided by 2, and the answer was 4, remainder 0. Okay, great. We see all that. So what's the answer to the question? What is the greatest common divisor? What's the greatest number that commonly divides into 374 and 98? Where is it? Well, it's this number right here, which in this case is 2. It's the number 2. Why? Why is it that number 2? Because that's the last divisor. Remember, these are all divisors. These are all the numbers. It's the last number you were dividing by. The greatest common divisor is the last divisor when you got a remainder of 0. There it is. And so there's the method. That's Euclid's method. That's the Euclidean algorithm, Euclid's method for finding the greatest number that divides into 2 big numbers. Is you just keep long dividing and rotating, right? We long divide and then we rotate. We long divide and then we rotate. We long divide and then we rotate. We long divide and we rotate. We long divide and we rotate until you get a remainder of 0. As soon as you do, that last divisor is the answer, the greatest common divisor of those 2 numbers. Questions I can answer on that one?